In this video, I'm going to draw free body diagrams for the two situations you see pictured and described here. The first one's actually already done for you in your note packet. It's a crate being pushed across a frictionless floor. So the first thing is to make sure you identify what the object is. And so we are analyzing the crate. And it's already labeled here. If it wasn't already labeled, I would be writing it down. We represent the object just as a dot, a free body. We're not drawing the floor, we're not drawing the man on our free body diagram. It's fine to draw a sketch of it if there's not already a sketch. But when you go to draw the free body diagram, you just want to have the one object represented and then draw the things that it's interacting with. Now there's one non-contact force that's acting here, also called a field force. And you'll see this on almost every free body diagram. That is the weight or the force of gravity. So this could be represented as W or mg or Fg. Any of those symbols are fine. There's also a force from, well, now that we've gotten the non-contact force out of the way, we can think about what it's in contact with. It's in contact with the floor. The floor can exert two different forces. It can exert a normal force. Normal force is always perpendicular to the surface. In this case, the surface is horizontal, so the normal force is straight upward. The other force that the floor could exert would be a friction force. But the floor is frictionless in this scenario, so we don't have that to worry about. What else is touching the crate? Well, the man is. The man is pushing on the crate to the right. So we could call this the applied force. We could also call it the force of the man. Now there's no grid behind this one, but this length of this force and this length of the weight, these two forces are equal. So we draw them the same length because those two forces are equal. The force of the man, we don't know how big that is. It could be bigger than the weight or it could be smaller than the weight. We don't really know. Any force that he exerts is going to cause the crate to accelerate. All right, now let's look at the child sled system. Okay, so our system that we're drawing a free body diagram for, I'm circling it here. Okay, that's what we're analyzing. That is the child sled. It's a system of objects. So now the same thing applies as the last one. What field force is operating? Well, there's only one field force in Physics 111 that we need to concern ourselves with, and that is the force of gravity, or the weight. Okay, so I could use any of these symbols. I'm just going to use weight in this particular one. And then we have a normal force, because it's touching the ground, and there is a force. Well, what else is it touching? There's a force from this rope. Okay, the rope is touching the system. There we go. And then it says, do consider friction, and we're going to draw that in. And this friction would be kinetic friction because the two surfaces are sliding relative to each other. Now let's look a little more carefully. If we look at the upward forces, this force is one block upward. This force is 2 blocks to the right and 1 block upward. So we have this 1 block upward and this one is 1 block upward. So that's a total of 2 blocks upward, and we also have 2 blocks downward. And so that makes sense. So the relative sizes of the forces are important here. Now it didn't say how this was being pulled, whether it was at constant speed or speeding up or otherwise. But let's just make a note, being pulled at constant velocity. Okay, so we'll say being pulled at constant velocity. Well, that means the forces have to be balanced in accordance with the first law. If the velocity is constant, the forces must be balanced. So 2 blocks of force to the right and 2 blocks to the left It's just a relative scale. Those could represent newtons or pounds or what have you. But we can see that the force to the right is equal to the force to the left. The total force upward is equal to the total force downward.